Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at indices or powers. This is part 1. Make sure to subscribe so that you don't miss out on any of our future uploads. In the meantime, I encourage you to check out the following videos, all on Numbers Simplified. And I encourage you to check out the factors list. In this session, we look at expressions of the form x to the power a, where x is the base, a is the index or power, and x and a are elements of real numbers. Calculators may not be necessary in this session. For instance, if we have 9, we can express it as 3 to the power 2, where of course 3 is the base, 2 is the index or power. Note, indices is the plural form for index. Let's look at example 1. In example 1, we are meant to express 125 in index form, and I encourage you to check out the factors video. The solution. Recall how we find the factors for a number. We divide by the smallest prime factor, which is 5 in this case. Dividing that into 125, we get 25. Divided by 5, we get 5. Divided by 5, we get 1. Therefore, 125 is equals to 5 to the power 3. Example 2. Express 2 to the power 5 in full. So this one will be an easy question because we've got 5 2's. Multiplying them by themselves, we get 32. Now let's get into the laws of indices. Starting with the positive indices. Law number 1, the multiplication. If we have x to the power a times x to the power b, that means that the base is the same. Therefore, we add the powers. And note, we don't multiply the powers. Let's look at example 3. We are meant to simplify a to the power 5 times a to the power 2, the solution. So from law number 1 of indices, we see that we have the same base, which is 8 in this case. Therefore, we can actually add the powers. That is to say, a to the power 5 plus 2 is equal to 8 to the 7. And note, we don't have it as 8 to the power 5 times 2. And you can always check this one out with your calculator to see the correct answers. Right, let's look at example 4. Simplify the index. So we have the same base. So according to law number 1 of indices, the base is 4 for all the terms that we have multiplying each other. Therefore, we can apply law number 1, then implying that we are going to have 4 to the power 3 plus 5 plus 1, totaling 2, 4 to the power 9. Now, we can check using the calculator, of course. Let's look at example 5. Simplify the index that. This time around, what we recognize is we have numbers that have got different bases. So how do we go about this scenario? So from law number 1, we would have that, but then we can actually express these numbers as common bases, separating the bases according to like terms. That is to say, we have the 4s by themselves in their own brackets or parentheses, and the 5s by themselves as well. In that case, we move on to apply the law number 1 of indices for the first base 4, so that we have 4 to the 3 plus 5 times 5 to the 5 plus 4. Simplifying that, we are going to get 4 to the 8 times 5 to the 9. Let's look at law number 2, 1 on division. So if we have x to the a divided by x to the b, what we do is when we have the same base, then we simply subtract the powers. That is to say, we have x to the a minus b. Note, we don't divide the powers. Let's look at example 6. Simplify 4 to the 6 divided by 4 to the 2. Solution. From law number 2 of indices, we are going to have 4 to the 6 divided by 4 to the 2, which is equivalent to 4 to the 6 minus 2, so that we get the answer 4 to the 4. Now let's look at example 7. Simplify that. So with this one here, we're going to make use of a combination of the laws. Now, firstly, we consider the first law of indices, that is the multiplication. So we multiply the numerator and also the denominator separately, so that when we follow the first law, we have x to the 6 plus 7 divided by x to the 2 plus 8, since we are multiplying here, so that we get x to the 13 divided by x to the 10. So from here, we apply the second law of indices, which is the division. In that case, we are going to have x to the 13 minus 10, so that we get x to the 3, or x cubed. Now let's move on to law number 3. This one is about the power multiplication. When do we multiply the powers? So when we have x to the a, then we have the brackets or parentheses, a power outside the brackets or the parentheses. That is the only case we multiply the indices, so that we have x to the a times b, or x to the ab. Let's look at example 8. Simplify that. So according to law number 3, what we would have then is 5 to the 2 times 2 to give us 5 to the 4. Why? Because we have a power that is outside the brackets or the parentheses. Example 9. So we are meant to simplify a fraction of this nature. And take note, we don't have the same basis throughout. So we may need to separate according to the bases. Now, working on the numerator by law 3, what we would have is that, and then so since we have the powers outside the brackets or the parentheses, we multiply the powers that are inside, so that we have x to the 10 times y to the 12, and the denominator remains the same. So after dealing with the numerator, we can then separate the bases, that is to say, separating the x's by themselves and the y's by themselves, so that we have that. Now, in this case, we are able to apply the second law of indices, which is the division, so that we have x to the 10 minus 8 times y to the 12 minus 9. Why? Because we were dividing these according to law number 2. Now, simplifying further, we are going to get our final answer as x squared y cubed. Law number 4, the zero index. X to the 0 is equals to 1. So this applies to all values. So all values raised to the power 0 would give us a 1, positive or negative. Rational, irrational, it doesn't really matter. Now let's have a quick recall. So remember, x to the a divided by x to the a would give us a 1. Also, from law number 2, if we have that scenario on the left-hand side, that is equivalent to having x to the a minus a, so that we get x to the 0, implying that x to the 0 is equal to 1. That is the fourth law of indices. Let's take a look at example 10. So we have that. So the solution then we know that 2 to the 0 is equals to 1. Therefore, 1 times 2 to the 3 is equal to 2 cubed. That's our solution. Example 11. We have that scenario there. And then we know that inside the brackets or the parentheses, we are going to get a 1, because any number raised to the power of 0 gives us a 1. So we just have 1 squared, which is 1. That is our final answer. Now, let's look at negative indices. So with negative indices, we recall from law number 2 of division and law number 4 for zero indices. If we have x to the power minus m is equals to, that's the same as having x to the 0 minus m, which is the same as having x to the 0 divided by x to the m, which is expressed as that. Now that would simplify to 1 over x to the m, implying then that x to the minus m is equal to 1 over x to the m. So that is the fifth law, the negative indices. Let's look at example 12. We are meant to evaluate that. So the solution. According to what we know, we can use the first law of multiplication. That is to say, we express 4 as 2 to the power 2 times 2 to the power minus 3. And applying that, we just subtract, or rather add the powers, which are subtracting in this case, so that we have 2 to the 2 minus 3. And that will give us an answer of a half, according to law number 4, or rather 5. Now, let's look at example 13. So with example 13, we have 6 times 10 to the power minus 2. So the solution is that. We know that we can express 10 to the power minus 2 as 1 over 10 squared times the 6. And we know that 10 squared is equivalent to 100. If that is the case, then that would then simplify to 6 over 100, which is simplified to 3 over 50. Example 14. Evaluate that. So now with this example 14, we are saying from law number 2 of division, we can actually simplify our work in this manner. We have x to the minus 6 minus 8, which becomes a positive, so that we have x to the minus 6 plus 8. Then our answer becomes x squared. Law number 6, the fractional indices. So if we have x to the power 1 over a, then that will be the 8th root of the base x. Let's look at example 15. Evaluate 27 to the power 1 over 3, the solution. So we can actually have this according to law 6. We find the cube root of 27, which would give us a 3. Or alternatively, we can actually use law number 3. So using law number 3, we know that 27 can be expressed as 3 to the power 3. Then we have a power that is outside the brackets or parentheses, multiplying what's inside. So that when we expand, we multiply the power, so that we have 3 to the power 3 times 1 over 3, giving us 3 to the power 1, which is the same as a 3. Let's look at law number 7. So law number 7 is about fractional indices once again. So now if we have x to the power b over a, then we can have a situation in which we find the 8th root of the base x, then multiplying or raising everything that we get to the power b, or we start by raising the base to the power b, then finding the 8th root of what we have obtained. So let's look at example 16. Evaluate 9 to the power 3 over 2, the solution. Method 1. This then means that we can actually find the square root of the base 9, which is 3, and we raise it to the power 3 to get 27. That's the first approach. The second approach, we can actually have it in this way. We know that 9 can be expressed as 3 to the power 2, and raising everything to the power 3 over 2. Now that will be equivalent to having 3 to the 2 times 3 divided by 2. So the 2's will cancel out, so that we have 3 to the power 3, and that gives us a 27. We can have method 3. For method 3, what we would do is we would start by raising the base to the cube, so that we have 9 cube, then finding the square root of that, so that we have the square root of 729 to get 27. Let's look at the last example for the day. So we are meant to evaluate that. So the solution. Right, so for the first part, we are going to use law number 3 of multiplication because we've got x squared in brackets or parentheses. Then we have 3 over 2. So that would multiply, the powers would be multiplied so that we have x squared times 3 over 2 and the 2's will cancel out. Then we deal with that part of the numerator so that we have x cubed with the rest of the terms remaining the same. So simplifying that from law number 1, where we are adding the powers, since we are multiplying the terms, we are going to have that x raised to the power 3 plus minus 3 over 2, which would then simplify to x to the power 3 over 2 divided by x to the power 1/2. Now, according to law number 2 of division, that would then translate into having x to the 3 over 2 minus 1 over 2, so that we get an answer that is of that nature. Our x becomes x, like our answer becomes x. Right, if you've made it thus far into the video, I say congratulations to you, and I leave you with the following task. Make sure you don't use a calculator in getting the answer. Only use the calculator to check your answer. Remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Your experience in our sessions is of great value. Your preferred future topics is valuable to us. Your questions, concerns, and suggestions are always welcome. Thank you so much for watching Numbers Simplified. God loves you.